Okay, a bunch of derivative rules all being thrown at you at once. Okay, we'll run through these real quickly and then work an example. All right, constant multiple rule. If you have a multiple out in front of a term, coefficient on this term, it can basically come along for the ride and then take a derivative of whatever's next to it. The sum or difference rule. If we have multiple different terms, we can treat these as individual little problems, like little individual functions. Take the derivative of each one individually and keep the same sign in between. That works for either sums or differences. All right, next up, the power rule. If you have x raised to a power or a variable raised to the power, exponent comes down in front, reduce the exponent by 1. If it's simply a constant without a variable next to it, the derivative there is going to be 0. Derivative of x, a linear function, is going to be 1, or the number out in front. E to the x's derivative is always just e to the x. Now, if you have a different base besides e, what we do is it's going to be the natural log of that base multiplied by that base raised to the x power again. You can think of this as being the same rule for e to the x, but if it was natural log of e out in front here, that means the same thing as 1. And finally, this comes up sometimes, the derivative of natural log of x is going to be 1 over x. All right, so let's jump right into one of these, trying to take the derivative of k of x. In this case, k of x is this 10th degree polynomial. What we're going to do is use the power rule repeatedly. Just one term at a time, dealing with these as we go. So constant can come along out in front, that coefficient maybe I should say, and then the derivative of x to the 10th is going to be bring down the exponent, reduce the exponent by 1. So 10 minus 1 makes 9. All right, same idea on the next one. We're going to bring the 4 along. Again, we're looking at the x to the 5th. We're going to use the power rule. Exponent comes down, reduce the exponent by 1, minus 1.7, and then the derivative of x is going to be 1, or it's going to be that number out in front. I'm going to write a times 1 for the time being. And then at the end here, we're looking at 1003. Well, that's a constant. The derivative of a constant is always going to be 0. Now let's clean this up and give the best answer possible. So we have 5 times 10 makes 50, x to the 9th, plus 4 times 5 makes 20, x to the 4th, minus 1.7 times 1 is just 1.7 plus 0. And that's the best derivative we can get to in this case. Hope this helps out. Keep working on them. It takes practice.